Bonjour, good day from everywhere, anywhere you are. Welcome to this Snack and Learn webinar. My name is Nicolas and I'll be your co-host today. So we will start the presentation now. People are still connecting. I will start with some housekeeping items. We'll be doing the presentation and we'll have a Q&A, a question answer session at the end. So feel free to post your questions in the chat box of the GoToWebinar platform. You'll also see in the same GoToWebinar window that the presentation slides are already available in the hands out box in the same platform. So welcome to this Snack and Learn webinar. Today we will share some thoughts and experience with considering impacts of climate change on contaminated site management. My name is Nicolas Sbarrato. I'm based in Quebec City. I'm lead advisor for the climate risk and resilience at WSP Canada, and I'm with my colleague Dan.
Hi everyone, Dan Humphrey, advisor with our climate risk and resilience team in WSP Canada, and looking forward to the chat, and thanks for all coming.
Thanks, Dan. So our presentation today, I will start by introducing the context of the discussion, why we should consider climate change, and what are the challenges that our team managed to overcome through the different projects that we've been working on. And then Dan will take over to present a couple of case studies to illustrate those challenges and the different project examples that we've been through. Hopefully fostering some reflection and thoughts for the Q&A session at the end. So let's dive into it. So why considering climate change for contaminated sites, and why doing climate risk assessment? So obviously, we all know that contaminated sites are very complex systems already, and all of those system components are very closely influenced by climate change. So maybe by the location of the sites, some maybe in sensitive areas along shorelines or near water bodies, the different contaminants that can be present on a site and their behaviors in transportation or pathways can be very complex too and interrelated. The sites that are managed and the technologies and strategies that are used to remediate the sites can occur through long time spans and over very long time horizons. So climate change obviously fall into the critical criteria to consider. And within nature and ecosystem within which the sites are included, embedded, and interact with, makes for another important consideration where climate change can have impacts. So basically, the projects and the assessments that we've been doing tends to create value and bring more value to the already existing approach to manage contaminated sites. So we are adding this climate lens above existing assessments like robust and resilient conceptual site models that take climate change into account. And also when it comes to selecting and choosing the best remediation strategies, we're adding also this climate-driven decision-making to make sure that the choice that is made today also stands for in future climate conditions. So it's really to bring that long-term strategy and decision-making based on climate consideration, and to optimize the site management and avoid any reopening of the site or get to a closure that is taking the future conditions into account. Another driver also that brings climate risk assessment as important for contaminated site management are the different drivers that we see more and more in the industry. So some come from requirements, some come as requirements and incentives coming from different government bodies or the legislations where we operate. For example, here in Canada, the government of Canada has issued the greening government strategy, where resilience has to be embedded in all the government assets management strategies. Same goes south of the border here with the US, the United States Environmental Protection Agency, where resilient remediation is a big concern. There are also some drivers coming from the good practices that we see more and more with the industry developing. So maybe through site investigation practices or remediation and risk management strategies, as I mentioned before. So making sure that we not only produce assessment today, but we also take future into consideration. Funding and grants also tends to require more and more requirements related to resilience or adaptation to climate change. And finally, the last driver is around responsibilities as practitioners. So it can be through climate disclosure requirements, as we see in ESG, environmental, social, and governance targets, or also some TCFD, so disclosure related to climate for finance or for other requirements where climate is driving the decision. So we have seen through our different projects, different questions that we have started to think about and we are trying to overcome. So those concerns go around and are very common for contaminated site managers. So circling around, how can I prioritize a large portfolio of sites? How can I screen it to make sure that I'm making the right decisions on what to prioritize and focus on first? We are also covering a lot of diversity in terms of region or even climate specificities from one side to the other. Again, looping back to the complexities that I touched about earlier, each site has an individual context and a very specific complexities. So it's also important to consider, and it can be a concern. And then, so once we've managed to grasp all these questions, how can we prioritize and make informed decision on site management? So the next few slides, before we go into the site, the case studies, the next few slides are trying to summarize the three main challenges and context that we worked on. The first one is obviously working with complex and diverse climate site data. So we rely on an internal custom climate tool that has been developed by our team, which is based on the public available global climate models. And then we'll build upon this data set to create some informed and specific site scale data. So we are able to extract data from a global coverage to a very site-specific location, and it can be one or several multiple sites, so helping to support portfolios. And then from this, we draw upon a high customization option through the tool to extract data, climate data, based on really the site requirements. So it can be custom time horizons depending on the time frames that we want to cover. We also have the choice of different climate scenarios. We can draw from a very long list of climate hazards and indicators to make sure that we project data relevant to the different site components. And then obviously with the computational power, we're able to draw some statistical analysis and time series, for example, to figure out or illustrate the scenarios, the climate scenarios that we want to consider for the assessment. So we really use this tool more and more, and you'll see in the different case studies that Dan will present later that it's the basics of everything that we do in those assessments. The second challenge that we have been facing and that we've found a way to overcome is around the complexities of contamination, obviously. So we've drawn upon our internal contaminated site expert network to allow us to assess all those different interactions and complex processes that happen on a contaminated site. So here is just an example of how complex it can be. So it's only presenting on the slide the contaminant transportation with a change in precipitation. So we already see that there is a lot of different ways and interactions and possibilities of impacts between the different components, water bodies that are present, or even media that are present on a site. So we tend to draw on a system interaction approach where we are able to map all the processes really individually and see how climate change can impact each of the processes. So think about a conceptual site model within current conditions upon which we bring a climate change lens, so future condition conceptual site model. The last challenge here that we want to draw your attention on is, okay, we have a large portfolio, a lot of sites, different conditions, complex conditions. How can we manage multiple priorities and have an efficient decision making? So we have been using this multi-level approach from 3 levels, where we start at a very high level, level 1, which is really analyzing any gaps that can be existing on the knowledge of climate change on the sites, and then screen the portfolio to single out the most critical assets or sites. Then level 2 brings us the opportunity to evaluate and validate the selected critical sites from level 1. So to confirm any assumptions or start to go into more details to get to the site specificities and understand, okay, this site is more critical than the other, so we prioritize it. To get to that last level, level 3, which is really to develop some specific assessment based on specific plans and CSM detail of the sites, of the highest risk sites, so that then we can develop adaptation planning and adaptation solutions to bring to improve resilience and bring adaptation to the sites. So let's now see some of our project examples for each of the 3 levels. Dan, over to you.
Awesome, thanks, Nico. So yeah, I'll be showing case studies that we've recently completed at each of these levels, and the idea here is to demonstrate how each level assessment can build and integrate with the previous level and how it all works together. So the first case study in our level 1 assessment was a climate change vulnerability assessment, so a portfolio assessment across numerous sites, large spatial boundary. Again, the objective of a level 1 assessment in our methodology is to identify where climate vulnerability may exist in the portfolio and flag that for future consideration. So how did we do this in this particular example? We did it through an archetype assessment approach. So an archetype and assessment allowed us to group sites into particular categories where we're assessing and having parameters around our methodology for like sites. So we're comparing apples to apples. We were able to use our internal WSP climate tool to look at climate projections across a very large spatial region for our sites. We developed archetype-specific sensitivity indicators to help us evaluate what would make a site more sensitive to various climate hazards. And combining all that, we were able to provide climate vulnerability scores across the portfolio. This helped prioritize which sites would be of concern and warrant future evaluation or prioritization. The other interesting thing or unique thing about these types of assessments, there's generally a lot of purposes and a lot of eyes on these assessments. So they need to be able to provide different ways of presenting information. So from the site manager to the regional manager to the higher level managers and portfolio managers. So we do this in a couple different ways of presenting data. We can provide kind of site snapshots of climate vulnerability and impact at a particular site. So these can be printed for individual site results, but also we can tie it into larger GIS and dashboard systems where we can toggle on and off different criteria to make informed decisions. So moving from a level 1 assessment to a level 2 assessment. So a level 2 assessment objective is to take those prioritized sites that were identified in a level 1 and refine them. Verify that climate vulnerability exists at these sites, and we want to start prioritizing and laying out a timeline for action, because on contaminated sites, we could have a portfolio that are in different stages of their site management journey. It could be early stages in investigation right to sites that are going into that risk and remediation strategy development. So how do we do this? We want to, when we're able to prioritize and look at a finer amount of sites, we can pull in site data that wasn't possible at the portfolio level. So we can go back at these sites, see what's available. We can refine our climate projection data to help validate and determine that kind of more tailored list for action. So in this particular example, we had a large number of sites in our portfolio assessment. Level 1 assessment left us with 10 sites of prioritization across 3 different archetypes. For this particular evaluation, we are looking to whittle this down to 5 sites for the next year based on kind of budgetary constraints. So how did we do this? If we take a snapshot of just archetype 1 sites, we were able to pull in additional data, site investigation data that helped us refine our climate vulnerability and risk analysis. We were able to refine our climate data projections and our indicators that we were using our internal data set tool. And then the results, when we're just looking at the archetype 1 sites, we can see that overall vulnerability in case study 2 was higher in general. We also identified in our background review that case study 2 site was further along its remediation and risk management strategy. So it was more imminent that climate adaptation needed to be considered. So case study 2 was prioritized for this year's next steps. Okay, moving into a level 3 assessment. This is an assessment that is at the site level. It's our highest granularity. What we want to do here is identify site-specific climate risks that may exist to the contaminant and its transport, as well as integrate climate adaptation and resilience strategies into the management strategies of that contamination. So in this particular case study, we did a site-specific climate risk assessment for an operated landfill. They have contaminated soil on site, and they are proposing to use a cap layer with a geomembrane and overlay layer. So the objective here was to identify how climate would interact and impact the remediation and risk management strategy, as well as what are the risks associated with the strategy or management strategy failing. So first, we did this by looking at the different interactions associated with the critical design criteria of the different components of the remediation strategy. Next, we looked at how the conceptual site model for the site could be impacted by different climate hazards. And this ultimately allowed us to provide informed climate adaptation and resilience strategies by climate hazard assess. So if we look at the next slide, Nico, we can have a tailored adaptation measures by climate hazards for our remediation and risk management strategy. In this particular case that we're presenting here, it was for a change in precipitation. So we had precipitation potential increasing over time at the site. This may result into more standing surface water on the cap layer. This resulting in erosion and ultimately causing exposure of the geomembrane and potential failure of the geomembrane, protecting the contaminated soil. So what are our adaptation measures proposed? Well, the first was to integrate climate data and projections into the design of the spillway and drainage system for the cap layer. This allowed or will allow for future precipitation capacity to manage that water. The next thing we recommended is to integrate permanent erosion sediment controls, or I guess more robust permanent erosion and sediment controls to manage excess water on that cap layer. And the final thing, as part of a continual improvement process, we can integrate climate change impacts into the existing site management strategy. So into the existing inspection programs, into the existing operation procedures. So before, during, and after significant weather events, and then a methodology to update the plan as necessary as part of a continual improvement process. So that wraps up our 3 case study examples at each of the assessment levels. So what are the key takeaways Nico and I want to provide you today is we're here to help. We're here to help you integrate climate-informed decisions into the management of your sites by integrating climate change into design, integrating resilience and adaptation into the decision and actions of your sites, providing defendable climate data and scenario analysis to help make those decisions and align the management of your sites with key industry drivers such as professional liability, evolution of practice, and climate disclosure. So with that wraps up our questions. I think we can get into the Q&A.
Thanks, Dan. Thank you very much for listening. So yes, we have already a few questions coming in. The first one, Dan, how can we take climate change into consideration for emerging contaminants such as PFAS, whose chemistry is not fully known?
That's a great question, and I think that's a difficult question to answer. I think you have to be adaptable, right? So as we learn more about the fate of new emerging contaminants, how they would react to different pressures and changes in exposure pathways due to climate change or climate hazards, we need to be able to identify that, observe that, and document that in our methodology strategies. It's also something that can be looked at very closely at a site level, right? So something we can use measured data points from a site, whether it's logger data or other site investigation data that we can leverage to help inform climate vulnerability and risk on those sites.
Great. Second question, how will climate change impact partially remediated / capped sites used as a parkland?
Right. So I think that really depends on your site, your specific contaminants of concern, what has been remediated, what has not, what is the cap construction. It really comes down to how sensitive your site could be to changing climate and what measures you have in place versus what measures you should have in place when considering climate change. So I think that question really depends on specific circumstance and specific sites and what's occurring at the site. But I think in general, the process is the same. We're going to assess impacts to climate change impacts to the contamination itself, its exposure pathways, transport mechanisms, et cetera, as well as climate impacts to the cap and provide adaptation and resilient measures based on those evaluations.
And one thing that is important also to note is that there is no bad time to start thinking about climate change consideration in the site assessment. So it can be when you already have your strategy in place, or when you're planning it, or even way before that, when you screen your site for contamination potential. You also can screen it to have an idea of what could be the climate hazard that are relevant for the site, and that will drive afterwards how you consider the impacts on the infrastructure, as you mentioned, or also on the contamination. Great. I think we have time for another question. Can you provide more explanation of how the archetypes are defined?
I can probably start that one off, Nico. So archetype development, it really depends on your portfolio. We could develop archetypes by different types of contaminants. So grouping contaminants that have like properties together. We could create archetypes by level of investigation. So is your portfolio have sites with different level of understanding of contamination on site? So i.e., do you have sites that are at your kind of risk remediation strategy development stage, or are you still just trying to identify contaminants of concern, delineate the site, et cetera? So there's different ways we can look at archetypes, but why the archetype approach is beneficial for contaminated sites in particular is we can customize our assessment methodology, right? So we can look at sensitivity and vulnerability indicators and sensitivity indicators that would be specific to those types of sites. Yeah, anything to add, Nico?
Nope. Yeah, that's great. Thanks. And we're at the end of our time today. So again, thank you very much for attending. Thank you, Dan, for presenting with me. And yeah, have a great rest of your day.
Thanks, everyone.